Some other examples, moving away from the pure data architect design into the data architect being aware of what the application people do. And I'll tell you a little bit more about SQL statements in a minute. MySQL has a data type called enumeration, and it actually took quite some time in my experience. I've been using MySQL since 1999 before I accepted enum as a column that I wanted to use. And the disadvantage of enum is that you can't change its set of values on the fly. It's a column. So, as I've discussed before, there's no online alter. So if you have an enum column with 3 values and you decide you want to add a 4th value, you have to alter the table. So you should choose your enum columns wisely. However, there are classic examples, and I was showing here, things of gender or status. When they're not going to change, you can define them as an enum, and you get 2 benefits. First of all, you can actually define the column as, in this case, male, and you'll actually see in a result set the word male, but actually internally it's going to be stored as 0 or 1. So it's only going to take up 1 byte instead of, in this case, if we were storing a database, it could take up 6 bytes. So the disadvantage obviously is if you had a status and you decided you want to add some new values, then enum may not be applicable if you don't have a strategy, a high availability to do online DDL changes and keeping your site available. A couple little tricks, particularly when you're using functions that store hexadecimal digits. What people don't generally realise is that you actually store it in a binary data type. You use the hex and unhex functions around that to actually store the value, cutting the number of bytes down by half. And practically every single site uses. Sorry, Rick. Go on. Yes.
I've seen VARCHAR being used for here. I've seen UTF-8 being used, which triples the number of bytes.
Yes.
I've seen case insensitive when they're using the 22-digit version of the hash.
Where they're using a collation. Yes. Yeah. So you know, this all comes back to understanding your data as a data architect. And many people in the room here will not be specialised data architects. You'll be filling many roles. Whether you're a DBA, whether you're an application developer, whether you're a manager who just wants your system to work well, or an investor who wants their money back. But the data architect, whoever's wearing the data architect hat, needs to make sure that you understand your schema. I'm an enterprise data architect by trade, so having a more traditional 500 table system, having that schema in my head and knowing every column, that's what I used to do. I used to scare all the developers when they would make a request for a change. It's like, no, it's over there in that column. So also understanding the type of data that you're storing is very relevant. IP address is a classic one. Everyone uses VARCHAR 15. But really, you can store an integer column, and MySQL has functions to convert that and perform better range searching on it as well. And I should just make a note, that's for IPv4. IPv6 makes it a little more complicated because you actually need 4 int columns. Or is it 4 big int columns? 4 int columns. Yes, go on the way.
Using IPv4 representing it as an integer, you still guaranteed to get ordering on an index that's proper?
Well, it's an integer column, so we'll actually order it by the integer value, not by the underlying. It multiplied by 255 for each of the 4 components of the IP address. So you're talking about ordering in terms of like, you want to order them by 111 dot so forth. Oh.
You just answered.
Okay, great, not a problem. So yeah, that happens every time. Normally you can take 12 bytes down to 4. This is one of my favourites. Not null. It can actually save you up to a byte, and the storage engines, depending on your use, will optimise this down into using bits per columns. But the significant thing, as I say down there in the best practice, like I said with unsigned, the rule should be always define your columns as not null, unless there's a reason not to. And one of the reasons why you should do that is because it provides another level of data integrity that you have against the database from any rogue application that wants to store data into your database which is not valid. Of course, if you have not null default blank, or quote, that sort of negates the purpose of having not null. And so even MySQL can be a little at fault by when you go show create table, and that gives you the syntax back. So it's important that when you're using columns, again, understanding the purpose of the data, realizing not only just from a design perspective what you want to do in terms of data integrity, but also the consideration of the space in terms of saving. And as I mentioned there, you also get an extra benefit with indexes. So it's one of those principles. Yes, go on.
I often use it when there's data that's being loaded at different times. Is there a better way to do that?
You often use
null, allow nulls, because some of the fields are going to be added later on.
Yeah, so the question was, I often use nulls. If you're working, for example, in a large environment, a large existing environment, and you already have a database that has data, you're adding a new column, and for example, you have a master and a failover master, you just can't create a column automatically by not null, because you have to put a value in it. And you don't want to define not null default value because you want to change that over time. So sometimes this is a matter of understanding your deployment of how you deploy software, where it's actually like a three-stage approach, where it's defined as null, and then a subsequent statement will set it to a default value, and then once you've rolled out the database changes across your masters and slaves appropriately, and you've rolled out your application code to your X thousand servers, then the next iteration of database management is to take that column and define it from nullable to not nullable. But as you realize, as we talked about earlier, online alter is a blocking statement. So if you want to deploy a not null column into a working production database, you actually have to go through the migration process twice, particularly if you have multiple databases and multiple application servers. So as your scale grows, the approach in which you design your databases and work around the present limitations will change the way in which you think about doing things. So in that period of time, you define a column as nullable, you set it as a default value, but your applications are still putting in values which are null, for example. And when you roll out all your application servers and all the code is putting in not null values, then you want to change the column back to not nullable, you first got to go, okay, well, let's again set any nullable column to the default value that we expected, and then change the column to not null. So in a smaller environment, in one database, a few slaves, or a couple application servers where you could sort of do it in a rolling few minutes for a maintenance downtime for a website, that's okay. When the alter is going to take 2 hours to get into your database, well, it's not okay. And when you have economies of scale, when you start dealing with like 5,000 web servers, rolling out your application is a process that takes days, not a matter of minutes. Know about character sets. Rick mentioned a little point before. MySQL has a wonderful ability to store different character sets of data. So any Japanese-speaking people in the room, or Klingons, or any of those that need more than 1 byte to store a character, we have UTF-8. But you don't need to define your columns as UTF-8 unless you actually need to define them as UTF-8. You can define UTF-8 at the database instance level, in the configuration file, at the database schema level, at the table level, and at the column level. I'll actually say that. I should read my slides. So one of the reasons why UTF-8 is bad is internally on disk, UTF-8 is fine. A value will be stored on disk as efficiently as it can possibly be stored. With the traditional storage engines of MyISAM and NODB, the appropriate buffer, whether it be the key buffer for indexes or the identity buffer pool size, is a mapping between what's on disk and what's on memory. That's also fine. But when MySQL uses the column internally in any internal memory structure, for example, creating a temporary table, it will expand that column out to the maximum possible value of that data type for its processing. The easiest way to think about that is when you want to wonder what's going to happen with your columns, create your schema with engine equals memory, and you'll see exactly how big that column will be, that row will be in the database. So you think your row width might be 800 bytes, and you do select star and something else in your tables, and you convert your schema table to memory, and you realize that it's actually storing 8K per row, because this is the way internally MySQL uses the memory management when it's working from a collation from individual storage engines. So again, it just comes back to principles. Don't use UTF-8 unless you need to. There are always examples for using it. Perfectly valid for people who have names that are not in English. As Dick said this morning, not everyone is American.